Hey guys, welcome back to another video for the backend database architecture. This is obviously in conjunction with the front end piece, understanding the way that Red Sky, that we do our servers and everything there. So let's see, to kind of start us off, I want to talk through the traditional standard setup for the way that this goes. Is obviously you have your clients, whatever it is, desktop, mobile, whatever, it doesn't matter, right? We're talking about the server. But that makes a request out to the internet. The internet does its lookup for DNS and it finds our servers or our proxy or balance server. That's where all of our requests come in. And then from there, it sends the proxy balance server, has routing, typically done through HA proxy, to route everything over to our REST servers, right? Which we can set up in a cluster. And we can scale this vertically or horizontally, it doesn't matter. It's kind of the nice thing about setting it up this way. And then from our REST servers, they can either talk to our database or database cluster, which we'll set up or have set up, or he'll talk to our Redis cache or a third-party system or whomever. It doesn't necessarily matter, right? Just wherever their data source is for whatever they're going to do. But it's just important to understand that the structure, the architecture of how this is set up is from your client, makes a request out to the internet. That finds our balancer, proxy server. This is where your certificate lives. This is where we register in the DNS, all of that stuff. And they make a request. They forward it on round robin to the REST servers. He goes out to whichever data source he needs and fulfills that request, then returns that response back to the client. So that's the overall super high level database, or not database, but server architecture and setup there. All right. Kind of the next thing that we have is internally, right? So this is internal to the app or to the REST server once you kind of get in. So we have several different layers here. Some of them are dependent, as you can see, on certain things. So whether it's mobile app, whether we have multi-tenant system, kind of whatever that is. But this is kind of the generalized data flow that happens in our server app, our process there. So the first thing that comes in, this is the middleware. So we come in, we do a version check. What this does is it allows us to determine which version of the app should be running. If somebody has, if we need to do additional routing, whatever it happens to be. We can do a version check here and, send people back, make them upgrade, make them install a new version, whatever. For the company finder, this is again for a multi-tenant system. So what that is if we have multiple companies or organizations, large entities, whatever, existing on the same hardware, we can determine what to give them and render certain pieces of, render certain websites or, whatever it is, give them a certain subset of data from the database, from the cache, or whatever it happens to be based on the company finder. We then go into authentication. You can see that there's the distinction between authentication and authorization. Authentication is username and password login, right? It is authenticating against the server as opposed to authorizing, where authorizing is saying, do you have permission to access this resource on the server versus authenticating against the server for your user and those credentials. All right, then we go into API validation. So we have a validation layer that ensures the validity of the data as it's coming through, making sure that in the case of a login, your username is a string and your password is also a string, not a number or Boolean value or whatever it happens to be, and making sure that you send those across. And we can enforce whether it has to just be those two values or whatever. If you're sending extra data, we can kick back the request in the validation layer as well. So it really gives us a nice level of control. The nice thing about this too is that once we get to our endpoint, we know that the data exists. We know that it's there relative to whatever our interface is that we've defined. So we can move forward with our code under the assumption that the validation has caught what it needs to catch, and we know that those pieces exist and they are there. We don't have undefineds, we don't have nulls, we don't have to do any checking in our API. We then go to the API endpoint, which is the route, right? So, API user login or whatever it happens to be, whatever that route is. So that's where it comes in and registers there. From here, we go into our service layer. Service layer is where the business logic takes place. So, the routing in the endpoint, it is bound to express to whatever HTTP method that you have as that request comes in, and it sends it off to whichever service it needs to. So again, in the login example that we're walking through, it would go into the user service or authorization service to perform that authorization or login request. And that's where the business logic would take place. Again, if we have a cached user instance, if we're using JWT for validation, whatever it happens to be, it's going to go through the right business logic associated with that specific client or app to do whatever it needs to do. Or it's a pass-through into the database and it just does its thing. So then leading into that is the data. Again, from the service layer, it can go anywhere, as we saw in that previous diagram. It can go to a Redis cache. It can go to a third-party integration. It can go into our database. It can go into another database. It could go into a Mongo, MariaDB. It doesn't matter, right? It goes into a data layer that gets the data and deals with that stuff. So it's segmented like this intentionally. So each layer doesn't necessarily need to know about the other one. If, for example, we do want to pull out the authentication and authorization into its own piece, into a little microservice somewhere, we can do that, and it doesn't affect the rest of the architecture of the system. So anyway, okay, so that's again super high level what the architecture and everything is. So we'll just move on to the next one here in a little bit. So thanks, guys.